Hello, it's another day. I don't know what noun I wanted to say after that. These problems are probably going to become more interesting and harder and as we go along. I may need to start budgeting more time. We'll see. Okay, we have a grid. Okay, so I am just going to do what it says. Okay. Well, I'm going to make an educated guess about the second part. So we're have to compare the pairwise Manhattan distances and what? Sum them up. And I'm just going to have a guess that right now we're expanding each row and column to 2 rows or columns if they're empty. But this expansion factor might become bigger or something weirder in the second part. That's just my feeling. So there's a couple approaches I can do with the first. I could literally make the grid where each row and column is expanded, or I can sort of work with this existing grid and take the column and row expansion into account while doing the math on it. And I think I want to do the second one because it's not obvious to me which will be easier to code just doing this part, but the second one seems more flexible for. Okay, so first we're gonna find all the positions. What are these things called? Galaxies. That's two. They're just called things. No, just something what? Okay, fine. Galaxy positions. Okay. And then we want to also track which rows and which columns have anything in them. Cool. So now we want to look at every pair, and there's a small thing here where we don't want to just loop over the whole thing twice because we need to not count each pair forward and backward twice. A to B and B to A are the same pair, so we're gonna do the slicing. Iterate over the first one, and iterate over the remaining slice, and we're going to diff them. And because it's vectorized, because I have a handy V class, I can subtract them. Okay, well, right, this is where we need to do some counting. Okay, so base distance is this, and then for do I have a min max? Yes, I do. Low R, high R. We're going to look at each dimension and check each row in between them. We can emit this. Why are they? Come on, these are ints. We're going to, if Okay, I'm gonna just gonna accumulate onto this. If R is not in, if it's not occupied, the row distance gets twice as large. And basically the same thing for the other direction. I realized, briefly panicked because I have a reused variable name, but I think these are fine. I need to make sure the R and C coordinates are not flipped. That looks good. Actually, well, we could accumulate everything to one variable, but that seems bad. Okay. I do want to test this, I think. Okay, that did not work. Oh, I didn't enumerate. Is 290 correct? It is not correct. This is in fact the Manhattan distance? Yeah, right, yeah. Up, down, left, right, one, or that. Okay. So, what's wrong? Three, four, five, six, seven, eight, nine. Yeah, that is the 3, 4, 5, 6, 7. I'm not off by one there. Let's check that we got those. Did I read this correctly? Anyways, containing no galaxies. Rows is I, looks fine. Yeah, not seeing the bug. Yeah, it's not obvious what the, Okay. It's too low, 290 is too low. Oh, wait, this is wrong. Yikes. There we go. Yeah, I basically called it. Hello. Chad asks, why am I not doing it this year? It's... What did I not read this correctly? I'm not doing it this year live because, well, partly it's just too stressful too often, and partly I realized that I think being able to stream live and talk through my process rather than just optimizing for speed sounded more interesting. Oh, chat says, I didn't, you streamed, I just saw you recommended and recognized your name. Yeah, I don't stream really. Maybe I should start or get back into it. I streamed for very intensely at the beginning of the year, some puzzles, and then got Twitch affiliate, and then I was stopped. And there was some FF14 in the middle, but yeah, I don't know. This is not, I don't just think of myself as a streamer, but we'll see. Anyway, we have a bug. Okay. I didn't type zeros incorrectly. Man, it should have just been, I changed one number and it's just correct. But it's not, that's so sad. I guess we have to debug. That was right, it was 6:30, whatever. That's so sad. Okay, we debug, I guess. So if it's 10 and 1, that's too large already. Why is that? Oh, I see. Oh yeah, it's because we're off by 1, because this is how many more rows were there. So I actually want 9 and 9, and this should be a variable, but we're too close to bother. Okay, so the answer should be 9, 9, 9, 9, 9, 9. Or this is what we do. Okay. Yeah, off by 1. We have some, okay, so it looks like a grid, but it's not a grid. It's one-dimensional, and then it's also cases. Okay. Each row that's pretty non-trivial. Well, I mean, it's not. It's just dynamic programming. Okay, so we're trying to decide for each, let's get the actual, right, so each row is, so this is actually it's not a trivial dynamic programming exercise to think about, right? So this, I mean, it happens that this is like, what's the word? Like a nonogram clue, basically, but it's a kind of logic puzzle, but it's not directly relevant. Okay, so what does this dynamic programming say? So basically, yeah, okay, we're counting, like, it's pretty easy to think of a case where there are exponentially many arrangements. So we can't just list all of them. But what we do is a dynamic programming along the lines of, we want to match a prefix of this pattern with a prefix of the other pattern. I don't know what, they're both patterns. But the tricky part here is that these can be, so I think, how do I do this? There's also a sort of edge case. What I want to do is I want to take this right string right now and like expand into like this, which is like minimal, and basically go through and, okay, actually, yeah, I think this helps. So once we do the expansion, each of these dots gets replaced with one or more dots. It can't be 0. That's like kind of important. So then we have a pretty simple 2-index dynamic programming problem, except that there's a sort of edge case where the beginning and end aren't quite what we want, because you can skip any number of dots at the beginning and end. I think, did they say that? I think so. But we can get around that by just prepending and appending dots to both patterns at these, and then they must match exactly. So, okay, that's basically, I think I have a complete solution in mind. So what do we call these two patterns? I need a name for, no. Pattern and clue. These are both string. Well, okay. Clue equals. Okay, so that expands the right side into the pattern where each dot can be any number of dots in the left side, but the hashes have to match 1 to 1. And now we're going to just do a DP. Okay, cool. We're going to do it recursively. Recursively is easier, yeah. Think of less thinking. It's this. Is this the DB state I want? Yes, I think so. If, okay. And so the states are, well, okay, if I equals j, 0, or 1, it's a perfect case. If I, what is the, non-empty string to, yeah, otherwise, so okay, we've eliminated the cases. So now we know that pattern oh, there's an off by 1 here, which is really annoying. That's also a 0. This can be uniform. Okay, so possibilities are this, or so in this case we can either stay on J something like this. I think that's true. And that's bad. This is should we test on the sample? I think we should test on the sample. This is the sample, yes. Okay, it didn't work. Pretty typical. Okay, so we have to think about this TP somewhat carefully. Wait, what am I doing? I didn't even, I just ignored the question marks. Lamau, yeah, that. Oh, I see, okay. That's better, okay. This doesn't, that's still bad. That's not right. That's not the string I want to hear. Cool. Cool. That was non-exponential. We definitely could have listed all of them. 5 copies of itself. 5 copies of itself separated by question mark. What, like pattern for That didn't work. There's a missing bracket. Wait, that was the, wait, that's the wait. Oh, I typed the sample. Well, I know that it's good that the sample test case works. Okay. Cool, we got some, that was interesting. Get the transition right. Okay, we have more hashes and dots. What does that mean? Do we have to add some numbers and whatever? Okay. I feel like this sounds very familiar. I feel like we've had a similar problem before. So, oh, there's multiple patterns. Oh, okay, there's multiple patterns. Is it even guaranteed? Yeah, we can just, I mean, if we want to do this efficiently and everything, they're gonna be, you can do like hashes and stuff to find the comparisons, but I think we're just going to, do we have a transpose function? I do not. Do we have numpy? Whatever. It doesn't, it's totally fine. Okay, so, well, so we're gonna find such that and so we have, it has to be non-trivial. We want this, no, that is fine. Yes. Okay. So is it so? Is this thing a reflection about XS? For I. And there's like a little min here, but basically we're just gonna check, we're just gonna kind of do it. We're just gonna check all the rows and columns, or columns that have to be equal, and then if they're all equal, that's good. How do we do? So, okay, so r minus 1. We can go, yeah, so it's 2r minus 1. Right, so if j, so I and j reflect to each other if j is greater than equal to, it's out of bounds, we don't need to match it, otherwise it's just gonna match it. If excess I equals oh, we could do something very evil here. Okay. So if we've broke it, no, not equals. Okay, yeah, so this happens if break doesn't happen, and which means that they were all equal. Everything we checked was cool. So that works. Let me make sure this is the number I want to return. Or column to the left. Yes, that is what I want to return. Cool. So I didn't get the input. Yeah, these are paragraphs, so Okay, the thing we still need to implement is this part. And where we just, actually this is just, what is it? This is, I remember now, this is, how you write this in Python is just zip star. And do I need to list it? I bet I need to do that, but okay. Cool, that didn't work. Yeah. That seems about right. Okay. There are a couple of possible issues here. Let me just make sure that this actually looks good. Looks fine. Okay, so it didn't work. I want to see what this looks like. I mean, I think conceptually this should work. Oh. Actually, wait a second. Is it always between two rows? Yeah. Oh, it's either. Sorry, it's one of those. Oh. Oh, okay. Actually, is that rude? That's fine. Let me test. .405 is the sample, so we're gonna submit that. No. Disaster. Okay. Yeah, we should probably. Cool. Okay, so yeah, there is still an issue. Cool. What have we not found? I'm just double checking, make sure I saw this right. Yeah, 405, that's what I expect. 05 and then 40. Okay. And it does say that the reflection has to be between two rows or between two columns. Okay, so that means that something in our reflection finding code is wrong. Specifically, well, it's literally the second example. So we're on easy mode and we just literally look at it. Okay, let's see where the reflection should be. It looks like it should be r equals 6 like rows. So why is that not working? Did I do the math wrong? Probably I just trolled myself by writing a bad loop. Okay, let's. R minus 1 R. We're gonna spam so hard. I mean, this is what I expect to be true, right? Yes. So 3, 8 is false. Why is that the case? Did I not like? Oh, so actually my code is correct and these don't match. But is there some, is it not, did I not read correctly and like don't understand? No, they have to match exactly. Okay, that's actually not the right symmetry. So my code, that was not the issue with my code. Let's see. 3, I'm just dumb. 3, 8. Yeah, they don't match. There's an extra hash. Cool. Okay, where else is a possible reflection point? Oh, it could be just like literally this one, right? It's like kind of cheap, but I think it, I mean, yeah, why does my code not find that actually? That's a good question. I want to find the reflection where it's literally just 2, 3, 4, 5. Like, oh, I should go up to here. I see. That's how it goes. Off by 1, are very hard. Oh, okay. That's, yeah, okay. So now we want to find a thing where I guess you do the reflection and then the number of differences is exactly 1. Okay, so that's fine. Much of the code is the same. Well, this part is a little different. Let's see. So what are we going to do here? We're going to do this. We're going to have a little helper function that takes a list of rows or columns, zips them, and sums up these booleans. I should do the sample though. Okay. And I didn't say that again. Yep. That. Should I have done that the whole time? This was like easier to reason about. Oh well. Yeah. Let's see. I do think I might have been a bit. There are things I didn't super explain, but basically there's a bunch of code here that just sort of works regardless of whether you pass it rows or columns, even if the columns are tuples and the rows are strings, all we do is treat them as sequences, which is actually a technical Python term, in fact, for something that you can index into and that has a length. And so strings and tuples of single character strings are both sequences. And this code just sort of, when do you put asserts? Chat asks, when you put asserts? Basically when I feel like they might catch bugs. When there's like a very, when it's like hopefully not too hard to like check a condition, and I feel that there's a very high, if the sort of cost benefit of, if this assert fails, then there is a bug, and I think there might be a bug, so I want extra checks that that's the case. So yeah, like here is the problem had as a statement, like every sub-problem has a reflection that's either a row or a column. And I wrote code in a very sort of hacky way where if it doesn't find a reflection, it just returns 0 so that the sum works out. But there might have been a bug in the code, and in fact there was, right? So this assert checks that it found at least one of the rows, at least one row reflection, or at least one column reflection. Yeah, so it's like a problem enforcement invariant that alerts me to where a bug might be in my code. And that helped me locate, triangulate, narrow down where bugs might be faster. Okay, we have one more problem for this session. We have more grids, more O's, more hashes, more dots. This is a grid, okay. So we tilt, I think it's sort of vaguely obvious that we'll have to do more tilts in the second part. And part of the question is, do I want, like, the naive thing to do with these rocks is just sort of move them space by space until they can't move anymore. And that's probably fine, but it's cubic rather than quadratic. Or you could skip ahead and do it in quadratic. Actually, it's like kind of annoying. It's not. No, it's totally doable. Okay. Let's see. But I think takes enough brain power that I will just do the stupid cubic thing and move stones up one by one. So is there just one grid? Yeah, it's just one grid. Cubic's fine. So this is a list of lists. LMAP is a personal utility. It just maps eagerly. And for in fact, we can do the super naive thing where we just do as many scans as the height of the grid. Which is pretty funny. There is an off by one here. So we're gonna see if we can grid. If we can move a rock up, then we move it up. this is slow, but for part 1, there shouldn't be a problem. Okay, what is... And then... Okay, so... This... I don't really understand how this metaphor doesn't click in my mind. Like, I don't know why they're looking for this particular number, but that's fine. We're just gonna do it again. So 0, yeah, top row is this. If this height is 10, it's 0. 10 minus 0 is 10. And it's worth testing. Cool, we have an issue. Yeah, I transposed, despite my best efforts, I transposed rows and columns when adding 1. 136 is the right answer for the sample. Cool. That's what we're doing. Okay, and well, it's not obvious to me that the cubic thing will not. Well, let's see. Like, this will probably cycle after some number of small. Well, it's cheaper to test it. So we're gonna do. So we cannot simulate this 1 billion times. But so we're just we're just gonna do is make a list of all the states. So okay, what are we gonna do? Are we gonna just, is it worth, so I have to push the rocks in 4 directions, sort of obviously, and one question is, do we copy this code 4 times, or do we write a helper function? And I'm going to copy the code 4 times and change it, because it's kind of annoying to figure out the right parameterization to make the helper function viable and obviously correct. There is, yeah, like not doing this quadratically is, okay, sorry, I need to think carefully. I need to not off by 1. West. West means, yes, like that. And then I copy this code. This is terribly inefficient. Okay, so we're just gonna cycle it. Gonna put all the state into a single string. See, now add the state. This is an exploratory run where we just want to see if state will after a small number of iterations. Answer might be no. That's awkward. Well, okay, this did repeat. Okay. And how slow is this anyway? That's pretty slow. Okay. Do I think this will work? Well, we do know that we can say let's see. Oh, it did. Okay, that's a perfectly manageable amount of acceptable amount of repetition. So this will run. It takes a few seconds, but that's totally fine. So okay, sadly seeing these is not enough. We want a dictionary. So yeah, so after 0, yeah, so scene of a state is the number of cycles after which you've seen it, and at the very first rep, no cycle, it's 0. So we have to just find the period we care about. So when we see a state repetition, we subtract them. For all I know, this period is going to be 1, but let's do it correctly. So let's print everything, in fact. Okay, so we're going to do here. So n minus rep. No scene. So basically, we found a finite number of cycles after which the state loops. So that's the period of that cycle of cycles. Haha. To figure out where 1 billion lands in that cycle, we're going to subtract n from the cycle beginning. Mod out by that, and then like, what's the offset? So we need to find okay, I now wish I had this. I guess that was fine. Final state equals, you know, why am I doing this? This is gonna be a tuple. Row. This is which I you know, this is tiny constant factors. It doesn't. None of this matters. So we want to find the unique state in which the rep. See if v equals that thing. Try to convince yourself the cycle length is small enough. I mean, I ran code, like, it found a cycle within 137, so the cycle is less than 137. I did not, I thought a little bit about, like, if a state like this will actually produce a small cycle length. I think the answer is almost certainly no. Or actually, I think you probably could construct, like, this is true. Like, I think you can construct like a little thing that's like, oh, this part loops with period 3, this part loops with period 5, this part loops with period 7, and then by the Chinese remainder theorem, you're screwed. Yeah. There are, I think you can construct adversarial test cases, but that's just part of like the advent of code. They like probably don't. They aren't that mean, because if they are that mean, then people would complain on the subreddit and stuff. And I think it could be, it's just not. It's the sort of. It's not a traditional programming contest kind of deal. What was I trying to do here? I am trying to see They complain a lot of LCM problem. Okay, well, yeah, I mean, it's just it's very subjective. People have very different experiences. I, for one, like I remember when I did the LCM problem, my code was like completely wrong, or it just got very lucky that it got the right answer by being off by one, or in some complicated, like some parity thing that I like made two mistakes or one mistake and it just canceled itself out. But yeah, the adversarial, you could make much harder test cases for that already. And actually, yeah, I guess I'm not sure if the complaints are like this is too hard, or oh, this test case is too easy for given the general problem statement. I don't know. It's just super subjective. I think, having done this every year since now, like I think the part of the challenge is you just have to learn that sometimes the test cases are much easier than the problem statement, and that's part of the task. Figuring out in what ways it is. Way less correlation. This year, it seems like there's way less correlation between day number and difficulty. Maybe. What? How long have I been streaming so far? Where do I see this from the stream? This is a thing I can. How does Twitch work? Oh, here it is. An hour. Yeah, no, yeah, it's like. Yeah, I think the correlation is pretty weak. Anyway, where were we? I want to find that. Then break. Grid equals final state. .64 is correct for the sample. Now we wait a few seconds for it to hit 137. I don't even know, what was the period? Maybe, is the period going to be 1? That'd be really funny. The period was 11. Okay, that's like, it's a period. Cool. And so we come again to the end of the stream. Thank you, chat. I will see you in a few days again. Have a good December 5th. What am I trying to say? Have a good December 15th through 17. Goodbye.